Now, here we are in our examples of the recap. If you have our meets, we can ask questions, but this is simply a video recap of what we're going to cover in class. We're now at level 6. You should have already been through progressively levels 1 through 5, and each time they get progressively more difficult. We've kind of got to the conclusion that if we can get all of this stuff to be something squared equaling a number, that's our ultimate target. Well, we've got a number here, yay, but it's not as obvious how to get this thing into a square. So far, we've tried to split this in half, and it worked out pretty nice and easy. When it wasn't in half, we just simply multiplied the equation by 4. But this is where it's level 6 and different, because now our target to try to get a perfect square here is no longer going to be a perfect square if we multiply it by 4. Let's see. Erase this, and it zooms out, sorry. Okay, so I'm going to work over to my left here. So if we have our equation of 3x squared plus 5x plus 1 equals 9. So far, we have tried to make this and split it in half, and we multiply it by 4. So we times everything by 4. Let's just do that. 12, because it seemed like a pretty good idea. 12x squared plus 20x plus 4 equals 36. We can, when we do our box, we can split this 20 into 10, but we want this first number to be a perfect square so that when we figure out our numbers that produce that, they're the same. That's not going to be pretty. So what we're going to try to do is multiply this whole thing again by the number we started with here. So we're times everything by 3. Makes numbers pretty big. You might need a calculator if you can't catch up with all these numbers. And you might see that it is pretty big, but it works. The alternatives are a lot smaller numbers and fractions. So to avoid that, we make things bigger. 12 times 3, you may or may not recall. If you need to, calculate it. But you're also just following along anyways, probably. 36x squared. 20 times 3 plus 60x plus 12. Again, 36 times 3. 108. That's a big number. In fact, they're all quite big. But this number in front that we're looking for is in fact a perfect square. This is even, divisible by 2. We've proven those things in previous units that we've already covered, in fact, that what causes even, because it's divisible by 2. Perfect squares themselves are in fact numbers that multiply to each other to get that. So the first digit is going to be 36x squared in that box. This is going to get split in 2 to 30x and 30x. They're both positive because the 60 is positive. We've also seen that this is probably going to be 5. This is probably, what? Because of it was probably the number in the front in the beginning. 5x, 5x. Now, what's the square root of 36? 6. And 6x. Look at that. 6 times 6, 36. X and x. Oh, I guess I don't need this little x here because that's just simply 5, not plus 5x. My apologies. Plus 5. I can make mistakes too. Plus 5. But we kind of had a sense of that all along because this was what's going to, these numbers are relevant here. Now, 5 times 5, 25. So we want our constant to be 25. We're currently only at, over here, the biggest digit here, 12. If you don't remember how to get from 25 to 12, you can use a computator called a calculator. but if I add 13, that will make 25. If I add 13, that will make 25. So what do we get? Let's move it up a little bit here. In the end of all this little work, we have proven a perfect square on the left, that we have the same dimensions of 6x plus 5 squared equals, what is this big number? 121. Yay! I want to know why I say yay, because 6x plus 5 equals, wait a minute, I gotta square root that, 11, or 6x plus 5 equals the negative of 11, because that will multiply, get 121 as well. I'll move up here. Okay, so minus 5 minus 5. 11 minus 5 is 6. 6x equals 6. Well, divide by 6. What's 6 over 6? 1. Happy little 1. Nice easy number. Yay. All that work to get the easy number. Otherwise, fractions and decimals would be your problem to get there. Okay, minus 5 minus 5. Uh-oh. 11 minus 5 negatively is going to be negative 16. And we have 6x. Divide by 6. Divide by 6. Alright. Negative 16 over 6. And for those who will need to, which we should, probably reduce. They're both even, so it could be like 8 over 3 negative. A little bit smaller. But you've gotten the same process, and it's just a matter of reducing the fraction. Not a big deal. The whole same process you're going to get is you have still at least 2 answers from one of the positive square roots from creating the perfect square, or the negative square roots of creating the perfect square. And yeah, you get a fraction, but it's only one last step in the end. Makes it a lot simpler. I'm going to do a quick erase, and it's going to go back to the last question. Okay, so here we are, last example. Again, these take a bit of manipulation, but there's going to be some fruits of working with this method, because you can do it pretty much anything. It works well for all these problems that have integer base questions. When you have decimals, the problems become a little bit more tricky getting rid of the decimals. Okay, so we found that we want to split this. We want a goal, our target, as it were, is to make this a square number. We want to make this even for this one. We found that if we multiply by 4, that gives us the even. And if we now multiply by the number in front, that'll make this number a perfect square. So you can do it either or. Like, we need to multiply by 4, and in this case, the number in front is 5. So you multiply everything by 4 and 5. Everything. Okay, so if you want to do that in one step, that's times 20, by the way. I'm going to do that. 5 times 20. 100. X squared. 3 times 2 is 6 and a 0. X, and it's 20 times negative. And then 2 times 20 is plus 40 equals 80. 20 times 4, 4 20s, 80. Okay, moving along. We want to get a little grid here. It helps us organize our thoughts a little bit better. Just a wee bit. Wait for my drawing. Okay, there we go. So, perfect square, 100. 60 is divisible by 2. So, 100 goes here. 100x squared comes from 10 and 10. So 10 times 10 is 100. X makes 100. The 60 splits in half to 30x and 30x. And I said before, if you recognize that pattern, we can kind of figure out what goes here. Way back at the beginning, it was -3. In fact, how do you get from 10 to -30? Oh, shocker. -3. So those numbers still actually are there in the problem. We just made it usable. So minus 3, minus 3. I guess I should move down so we can see those numbers as they come up. All right, so 10x times negative 3, negative 30x, perfect. Negative 3 times negative 3 plus 9. Woohoo. Where are we at? 40. Uh-oh. Okay, we got to get from 40 to 9. So minus 10 is 30, minus 20 is 20. So minus 31. Yeah. Minus 31. Okay. Minus 31. That will give us 9. So minus 31. We've established now that we have a perfect square of 10x minus 3 is 80 take away 31. I'm going to do some old school. Take away 7, 10, 9. 7 minus 3 is 4. 49. Well, that's convenient because 49 is a nice number. We can undo the square now. Okay. And so we get, whoa, almost dropped the chords there. 10x minus 3 equals square root of 49, 7. Okay, or 10x minus 3 equals negative 7. Now we just finish off the last of the steps. We've always just simply added or subtracted this number, this constant here. So add 3, 7 plus 3 is 10. Woohoo! Nice and easy because 10x is 10. Divide by 10, divide by 10, and x equals 1. No big deal. On the other side, we have the or. We're going to add 3, which is the exact same as here. Add 3, add 3. So minus 7 plus 3, negative 4 equals 10x. Divided by 10, and then divide by 10. Okay, so we have x equals negative 4 over 10. Now, that would be sufficient in and of itself. We have an exact answer. They are both even, so you could reduce. 4 divides by 2. 10 divides by 2 is 5. So these would be your two exact answers. Now, they become really challenging if you try to do things straight away and start square rooting and reducing your numbers. But if you make the numbers big, go back into the original problem. If you manipulate your equation so that you have big numbers from 5, all the way to 100, oh well, they made pretty big numbers in the end. But you were only left with a single fraction at the very last step. So the advocacy is to recall all your steps here. Again, it's a long one just because there's a few more extra things. You want to make this even. So you multiply everything by 4. You want to make the first number to complete your square a perfect square. So you multiply by the leading coefficient. Namely, whatever it is, we call it a. Because we often recall from a previous year, that's ax squared plus bx plus c. Whoa, it just glitched out there. A. So you multiply by a, you multiply by 4. Everything is hunky-dory. That is it for all integer-based questions. You can follow along, pace your work here. You now have some practice problems that are based upon that. And we do have some situations to talk about in class about modeling problems. All right, have a good one.